We are going to see about the basic concepts of processing unit. The basic processing unit consists of a functional unit of a CPU called ALU and main memory and control unit. The fundamental concepts behind basic processing unit are fetching an instruction from main memory and updating the program counter for the purpose of fetching the successive memory locations and keep tracking of a program counter and keep track of instruction register and decoding the instruction, running the instruction as well as writing the result into the or back to the memory. If you want to execute a complete instruction, the very first phase is instruction fetch. That is fetching the contents of the memory location pointed out by the PC or program counter, and then the instruction will be loaded into an instruction register IR. That is, content of PC will be loaded with IR. And then we will be updating the program counter either by adding constant 4 or trying to obtain the effective address of the next location to be accessed. Once the data instruction is fetched, we need to update the PC and we need to fetch the instruction and we need to decode the instruction for the purpose of execution. So for that we will be using the other data path between memory and ALU will be used. The other components which is used or acting as a data path are MDR, that is memory data register or memory buffer register. So this MDR has 2 input and 2 output, since data can be loaded from memory or processor, either read or write. Both write as well as read can be performed only through MDR into the memory. And the other register is MAR, that is memory address register. It is a input line, don't have output. It is connected to the internal bus and output line is connected to an external bus. The memory address register is used for addressing the memory locations in the memory. And we will be using a set of control signal to control the activities of a CPU, and we will be using set of register, that is general purpose register, that is used for storing the operands, results and intermediate results, and we will be using some of the temporary register for the purpose of storing the intermediate results within the CPU. So this is the diagram, shows you single bus organization of a data path design of a CPU. This contains PC, program counter, MAR, memory address register, MDR, memory data register or memory buffer register, and Y is a temporary register, and multiplexer used for selecting constant 4 or the value present in Y register for the purpose of updating program counter. And the next component is ALU. This receives the set of control signal generated from the instruction decoder. Once the instruction is decoded, this instruction decoder is act as a timing and control logic. Once the instruction is fetched, the instruction will be decoded at the instruction decoder and it produces a set of control signal necessary for controlling the operation of ALU. So control signal generated by the instruction decoder will be connected to ALU, and the result of the operation will be stored into the Z register, that is a temporary register. and all these internal components are connected to the internal bus. Whenever the instruction is fetched, that will be loaded with the instruction register IR, and we will be having a set of general purpose register from R0 to Rn-1, and the temporary register, which is for storing the temporary results. Sometimes it stores the operand values. So this single bus organization of the data path design performs different operation. Initially, the PC holds the address of the operand. PC holds the address of the next instruction to be fetched, and that content of PC will be loaded with MAR for the purpose of addressing the memory location in the memory. From that address to memory location, either instruction or data will be received. If it is instruction, that will be loaded with instruction register. If it is data or operand, then it will be loaded with any one of the general purpose register or temporary register. Normally, for executing a complete instruction, we will be performing 5 different tasks. The first one is instruction fetch, and the second one is decode. The third operation is operand fetch, fourth execution, and fifth write back the results. Fetching the instruction from memory is called as instruction fetch. Decoding the instruction for the purpose of understanding the function of the instruction and where the operands are present, what kind of instruction format it is, what is the length of the instruction, what type of addressing mode it is supported. So everything will be understand after decoding the instruction, that is the decoding stage. And the third is operand fetch. Before execution, we need to know where the operands are present. The operands may be present in temporary register, sometimes it may be present in general purpose register, or it may be present in memory location, or sometimes it may be available in input output register. So once the data are brought into the CPU, then the execution will be done at ALU, and the result will be stored into the temporary register result. And then the result stored at the temporary register will be written back to the main memory, that is the write back operation. So these are all the basic operation we will be doing at CPU, and this is a diagram showing you how a particular word can be fetched from memory. For that, what are the components are involved.